Hello class and welcome to lesson 3.3, permutations and factorials. Now this is new stuff folks, and I don't think you learn this in any other class in high school except for data management. Please tell me if I'm wrong. However, for today you will need a scientific calculator and you need to look and make sure you know the locations of the following buttons. You need to find something that has an N with an exclamation mark. That's talking about factorials. And then your permutation button is going to be little n, capital BR. Quite often these are going to be the shift buttons of something else, so look for a different color. You may not have one button designated just for that, but it might be the shift of a certain button. On my calculator, it is the second button of 5 and second button of 6. So double check your calculator to find those buttons. Okay, let's do the warm-up, ladies and gentlemen. We're going to take a look at a couple examples, and then we're going to tie this into those new buttons and new terminology called factorials and permutations. All right, let's take a look at the first example here. If there are 6 students who owe Miss Smith a favor, she will choose one student for each of the next 6 school days to bring her a coffee. Okay, and it says no student will bring her coffee twice. How many ways could she choose the students? Well, first of all, how many days do we have, guys? Let's organize that. So we're going to say day 1, day 2, day 3, day 4, day 5, and day 6. Everybody good with that? Okay. Now, how many different people for the first day, how many options does Miss Smith have in order to pick? Well, if there's 6 students, she could choose any of the 6. Okay? And then we're going to times it by day 2. So day 2, she has to have picked 1 on the first day. So how many are left for the day 2? It's going to be 5. And then we're going to go 4, 3, 2. And by the last day, there's only one solution. So to figure out the number of ways, we're going to take 6 times 5 times 4 times 3 times 2 times 1 and plug that in your calculator, and you will notice that there's 720 different ways. Okay? Now you might say, hey Miss R, is there a shortcut to plugging that in the calculator? And yes, there is. We're going to get to it in a minute, but if you press 6 and then the factorial button, it should equal 720. Let me just double check on my calculator to make sure we got it working. So if I press 6, factorial, which gives you an exclamation mark, so it would look like this in your calculator when you're typing it in, and it'll equal 720. Okay, that's coming. I will show you how to press those buttons later, but it's just a shortcut. Okay. Oh, let's take a look at another scenario. So say, second part, if 2 of the students are Adam and Jessica, how many ways would have them bringing coffee in 2 consecutive days? So consecutive is a term you need to know in mathematics, especially in this unit, and they mean side by side. So it doesn't really matter if they go day 1, day 2, day 3, day 4, day 5, day 6, day whatever it is I missed, day 1 to 2, 2 to 3, 3 to 4, 4 to 5, or 5 to 6. Okay? So let's just go over this scenario. So if I go day 1, day 2, day 3, day 4, day 5, and day 6. Let's say we start with Adam going the first day, and because they got to be consecutive, then Jessica goes the next day. They are lumped together because they're consecutive. So if those go the first 2 days, how many people do I have left to go day 3? Well, hopefully you realize there's 4, and then 3, and then 2 people left, and then 1 person last day. Okay, so if I add those up, folks, remember the box of Adam and Jessica, they're fixed. So just 4 times 3 times 2 times 1 equals 24. Okay, but they don't have to go on day 1. They could go on, let's say they went day 2 and day 3. If we know automatically that Miss Smith's going to pick them to go day 2 and day 3, then we have 4 over here. Okay, times 3 times 2 times 1, because if those are fixed, then we still only have 4 people left. Okay, and again, that's 24. And notice you could do this 5 different ways. So how do we do that? Just think about how we organize those when we asked about the number of rectangles. So we can have 1, 2, 3, for 5 different ways. So there's 5 different cases, right? Okay, because it could be day 1 to 2, day 2 to 3, day 3 to 4, day 4 to 5, or day 5 to 6. Okay, so what does that mean for us, folks? That would mean 24 times 5 equals 120 ways. Okay? But you got to be careful with this situation here, guys. You could say, hey, Miss R, this is a full solution. However, it's not. Okay? When we did this, we did the assumption that Adam would go first and Jessica would go second. But what if we flip the order? What if Jessica went first and then Adam? Okay? Well, obviously that means, therefore, there's another what? 120 ways? Because you do the same scenario up top, but with just having Jessica and Adam reversed. So, therefore, there is a total of 240 ways, as long as we have 2 consecutive students. Okay? Awesome. Now let's get into this new fun stuff called factorials and permutations. Okay, so this is how we talk about in an introduction to counting problems. Okay, and in counting problems, we often see examples like what we had in our warm-up: 6 times 5 times 4 times 3 times 2. Well, this equals what I mentioned on the first page, 6 factorial. And that's what we call it, 6 factorial. Okay, that's how you read it. Okay, and so when you plug it in your calculator, you know that's going to equal 720 because we just did it up above. Okay, all right. So the definition of factorial notation is a formula. Okay, and this will be given on your formula sheet, folks. You don't have to write it out. But you start with n, and then it's to the subtract 1. So if it was, for example, 6 factorial, it would be 6 times n minus 1, which is 5, times n minus 2, which is 4, times n minus 3, which is 3, times n minus 2, and then you'll get to 2, 1, okay? So that kind of ties in here, okay? It depends on your patterning. And please note that 0 factorial equals 1 by definition. Okay? All right. Okay. Let's just do a quick example to make sure everybody's okay with this. So we're going to go 100 factorial equals, so it's going to be 100 times 99 times 98 times dot, 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 all the way to till you get 2 times 1. It's going to go all the way through there. Okay. Now, ladies and gentlemen, you need to test how many digits your calculator can do. Okay, there's only a maximum number these can do, because when you multiply these big numbers, you only have 9 or 10 decimal place values in your calculator. Okay, so please make note that 0 factorial by definition equals 1. Okay, and ladies and gentlemen, let's take a look at evaluating. So this is practicing plugging in your calculator. Okay, so 4 factorial, if I asked you to expand it, you'd be 4 times 3 times 2 times 1. But if I asked you just to solve it, you just plug in your calculator and you get 24. Okay? Now, a way to simplify a fraction that has both factorials in it is I'm going to do the higher number until it meets the lower number. So I'm going to go 8 times 7 times, I could go 6 times 5 times 4 times 3 times 2 times 1, but I'm going to just put to 6 factorial. And then what can I do to those 6 factorials? I can cancel it out. So shortcut is just to multiply 8 times 7, which is 56. Okay, you could, if I just asked you to solve it, you could plug in your calculator and it'll still give you the answer. But if I ask you to simplify it first, that's a way to simplify. Let's try another example here. So for C, it's going to be 75 times 74 times 73 times 72 times 71 factorial, right? All divided by 71 factorial. Okay, and then you can cancel out the 71 factorials, and you're left with, plugging that in your calculator, that's a big number, It's going to be 29,170,800. Okay. Good. So if you need help plugging calculator, please come see me. Let's keep moving on here. So the number of ways to arrange 6 students for 6 days is 6 factorial, like we mentioned. Each of these different arrangements is called a permutation. The total number of permutations an object of n is n factorial. So in permutation notation, this is denoted by npn. Okay? All right. And in this case, npn equals n factorial. Okay? So for example, if we have 6 days and we have 6 ways to choose them, sorry, put the wrong symbol down. Let me try that again. So 6 ways and we need to permutate 6 different days, 6 different ways. Okay, that equals 6 factorial. Okay? All right. Next one, but what if Miss Smith only wants coffee on 4 days? Okay, so if we take a look at that, we've got day 1, day 2, day 3, and day 4. Okay, so on day 1, we have 6 ways to do that. Day 2, we have 5. Day 4, we have 4 people left. And on day 3, we have 3. So you can't use just your 6 factorial here, folks. Okay, if you plug in your calculator, you're going to get 360 ways. And I'll show you how to use the permutation notation. So if you plug in your calculator, that's fine. However, here is the shortcut using permutation notation. If we have 6 people, but we only want it for 4 days, this is where you use that in your calculator. So go 6 perm 4, plug it in your calculator, and you're going to get 360. Okay, so this is kind of like our total, and this is how many we want. Okay? All right? All right, so let's keep going here. In the permutation 6 perm 4, there are 6 distinct items taken 4 at a time. Okay? Or an arrangement of 4 of the 6 items in a definite order. Okay, you can also see page 237 in your textbook if you're having trouble with this. Okay, and I'm going to show you a couple ways that we see the permutation notation. Okay, so our calculator, most calculators, take a look at yours. I think most calculators use the one I've highlighted. However, we can also see it in a comma form. I believe that the green one is more for when you are using like a spreadsheet or online data equipment to do it. Okay. So what does that mean? That means you're taking 6 factorial over 6 minus 2 factorial, which is the 2 different days left over. So that gives you the 4 factorial. Okay? So now let's compare that example. Let's compare it with the example from above. Okay? So we already did 6 perm 4. We know long form, it's 6 times 5. Times 4 times 3. How do you know when to stop? Because guess what? You have to do it 4 times. 1, 2, 3, 4. So start with your total. That's your start. Okay? And then you continue how many ever times it tells you. So that's 360 ways. Okay? Let's use this new notation up here. Okay? So 6 perm 4 equals 6 factorial over 6 minus 4 in brackets factorial. Okay, which equals 6 factorial over 2 factorial. Okay, plug in your calculator, 360 ways. Okay, so you can see it expressed both ways. Okay, all right, let's practice using with our calculator and make sure we can input these into our calculator. Okay, so use your calculator permutation key to find the following. Okay. So taking a look at this, if you wanted to expand it, that's going to be 8 factorial over 8 minus 3, which is 5 factorial. Okay, so just make sure that's the n minus r, if you're wondering where that comes from. Okay, so if we wanted to simplify, it's going to be 8 times 7 times 6, because the 5 factorials are going to cancel out. which is 336. Again, if I ask you just to plug it in, it'll give you the answer right away. But if you want to know mathematically what order it is and why you get that answer, I always want to give you the y. So this is the y right here. Okay? All right, let's try the next one. Okay. So the next one, if we put it into factorial notation, we got 52 factorial over n minus r, which is 48 factorial, which equals 52 times 51 times 50 times 49. Because if I do 48, the factorials cancel out. Plug it in, and you've got 6,497,400 ways. Okay. Moving on, we've got 10 perm 2, okay? So what that's going to be is 10 factorial over the difference between the two, so it's going to be 8 factorial. Plug that in your calculator, and that's going to be 90. Really, it's going to be 10 times 9, right, guys? Okay? All right, now we're going to get you thinking, now that you know the permutations, let's go over some examples here. So, consider the word numbers. Okay, how many different arrangements of all the letters are possible? Okay, well, how many letters are there? Make sure they're all different. So n equals what? 1, 2, 3, 4, 5, 6, 7. So 7 total letters. So how many possible letters are there? Well, it's going to be 7 factorial, which equals 7,000, plug your calculator, sorry, 5,400 ways. Okay, that's one way you could have showed it to me. Or you could say, hey, we've got 7 letters and we want to use all 7 of them. That's going to be 5,400 ways. All right, now we're going to get a little bit more difficult. Okay, how many 4-letter words? And even if they don't make sense, folks, as long as they're 4 letters, they can go together. You don't have to have a vowel. You don't have to have a consonant. You know, it could be any 4 letters put together. Well, first of all, how many letters do we have total? So the n equals 7. Okay, and what's our restriction of what are we looking for? We only want 4 of them. So you're going to go 7 perm 4. Simplify that. It's going to be 7 factorial over the difference between n and r, 3 factorial. So plug it in your calculator and you're going to get 840 words. Hopefully everybody's good with that. Okay. These are kind of cool when you think about it. How many ways are there where B remains in its original position? So when we write this out, 1, 2, 3, 4, 5, 6, 7, B has to remain in its original position. So N-U-M-B, okay? So B is stuck. So if B is stuck where it is, okay, how many different arrangements do we have? So B is fixed. So how many do we have left to start off with? We have 6 here, and then 5 here, 4, 3, 2, and 1, right? Or you got to realize that, hey, n equals 6 because we have 6 left over that are flexible to move around, okay? But B is fixed. So we have 6 factorial, which equals 720 words, okay? Or you could have said, hey, we have 6 free ones and we want to make 6-letter words from them. So we have 720 words. Awesome. Okay, D. How many words are there if the vowels stay together? So 1, 2, 3, 4, 5, 6, 7. How many vowels do we have, folks? Hopefully you know we have 2. A U and an E. Okay, so if a U and E go there, okay, then how many do we have left over? Okay, so they create one position because they can still move around, right? As long as they stay together, okay? So we'll call them 1. So there's 1 of them, and then, so they tie into 1, so there's going to be 6 total. So N equals 6, okay? Which means we can take this and place this 6 different ways, and then there's 5, 4, 3, 2, and 1 way after we move it, okay? And the reason there's 6, folks, is because remember, you can shift it along. Can I use this as an example? 1, 2, 3, 4, 5, 6 different ways, okay? So that's why that gives a notation of 6. Okay, the other one was fixed, so it just stuck there. Okay, all right, but this one, the vowel one is available to move. It just has to be, the vowels have to stay together, like that consecutive example. Okay, so when we take a look at this, folks, we have 6 factorial. Okay, and 6 factorial equals 720 ways. But please don't forget, the vowels have to stay together. So what about if we had E go first? Okay, so if we have EU, that's going to be another situation we got to remember. So therefore, there's 720 more ways. Okay, so that makes, therefore, a total of 1,440 ways. Everybody okay with that? All right, last one. Okay. How many arrangements have the vowels apart? Ooh. Well, remember last day we talked about the direct method versus the indirect method? I think this is better to do what's called the indirect method here. Okay? So we're going to do that. Okay? So, number of ways where the vowels are apart okay, equals, we're going to take the total number of ways, and don't forget to do the indirect method, you subtract the opposite. So what's the opposite? Is where the opposite case, so it says where the vowels are apart, we're going to say where the vowels are together, right? Indirect means the opposite. So you take the total and subtract the opposite. Okay? So total number of ways, we answered up in A. So that's 5,040 ways. Okay? Subtract the number of ways where the vowels are together, which is 1,440. Okay? Equals, plug in your calculator, 3,600 words. Okay. Now imagine if you were just trying to write all of them out to do that, you'd have to have 33,600 arrangements. That would take you a long time. So that's why, mathematically speaking, we find different ways to organize our data. You could have done the direct method here, folks, but it's going to take you several different cases because of the different arrangements that they could be, even though they were apart. They could be 1 apart, 2 apart, 3 apart, 4 apart, etc., right? Okay? So you'd have to add all those cases up. In this case, I find indirect method is the best. All right, so I would like you to, after I'm done talking here, please click on this link or copy and paste it and watch this video just to summarize today's lesson. Some of these videos have a strong British accent. Hopefully you can enjoy it. Here's today's homework. Page 239, numbers 3, 4, 6, 9 to 11, 13 to 16, and 22. Gives you a good practice on this. I know this is new, so if you need help, for sure, please come and see me. Have a great day.